This one is, of course, brought to you by the BCA, the Eastern Canada chapter. I, of course, am the current president, but more importantly, we've got Caleb with us. Caleb's going to go over the basics of building envelope commissioning, and yeah, so we've got this session outlined. Appreciate everyone for attending. Little housekeeping first. Please ask everyone to mute. Save your questions until the end, or you can use the chat box to put those together during the presentation. It should be about half hour or so, and yeah, you can put questions to the end too if you want. All right. This is going to be recorded, so I just want to make sure everyone's aware of that, and then we'll look to put the session online in some fashion when we can. Okay, so off to introductions. Obviously, as you know, Caleb Teeple is going to be our speaker and presenter today on basics of building envelope commissioning. Caleb is a professional engineer and lead accredited professional. He's the senior PM at Pretium Engineering. Caleb has 14 years experience in building science and engineering. Caleb is heavily involved with Pretium's building and envelope commissioning group and oversees multiple projects at a given time. Caleb joined our association and chapter in 2018 and was elected director last year. We're excited to have him and appreciative of his time for putting this together. So I'll pass the torch to you, Caleb. Up to you.
Excellent. Thank you so much, John. Yeah, so as John mentioned, we are recording now, just so you're aware. And John did mention in terms of holding questions. So just in order to keep the presentation moving, I'm not going to stop during it to take questions, but we will have a question and answer time set aside at the end. If you do have any questions as we're going, feel free to enter those in the chat. I won't be actively monitoring it as we go, but once we get to the question and answer session, I will go back through the chat and make sure that we address any of those questions that came up as well. So thank you so much, John, for the introduction. As he mentioned, I am one of the directors for the Eastern Canada chapter of the Building Commissioning Association. And one of our focus areas for this year is kind of doing a spotlight on the emerging market of building envelope commissioning. And because that's something our firm specializes in, I was asked to put together this presentation, and we're really doing kind of a high level overview of what building envelope commissioning is. I'm sure there's a lot of people here from a lot of different sectors of the industry. And most of you will understand mechanical, electrical, plumbing, typical MEP commissioning very well. And you probably have a general understanding of what that means to kind of take that process and put it towards the envelope of the building. But this will just kind of give you a little bit more information on what we do, what kind of process we tend to follow when we do an envelope commissioning project, and what the benefits are to the key project stakeholders. So without further ado, I will get started. So one of the central questions we want to answer is, what is building envelope commissioning? So I've got a quote here from ASHRAE Guideline 0 that says, the commissioning process is a quality-oriented process for achieving, verifying, and documenting that the performance of facilities, systems, and assemblies meet defined objectives and criteria. So as I mentioned, I'm sure a lot of you are quite familiar with that definition of commissioning and deal with it on a daily basis for MEP systems. When we take that same process and apply it to the envelope, we're basically trying to figure out ways to set aside key and discrete and measurable performance targets for that envelope and make sure that what is designed and what is constructed match, right? So that we're getting those performance targets hit. To take a quick step back, when we talk about the envelope, or as it's often known, especially in the United States, the enclosure of a building, that refers to any system or assembly that provides shelter and environmental separation. So we often think about that as the exterior shell of the building, and that can be the case most of the time, right? Certainly you're talking about your exterior walls, windows, roofs, slab on grade floors would apply as part of your envelope. It is also important to note, and part of the reason in Canada we tend to use the term envelope instead of enclosure, is that it can in some cases refer to interior assemblies as well. If you have something like a freezer, a sauna, maybe a pool enclosure inside your building, all of those have very different environmental conditions than the rest of your building. So any interior walls, ceilings, etc., that separate that space are also part of your envelope. All right, so why do we commission the envelope? Well, the primary reason is to ensure the owner gets what they paid for. Ultimately, when they're setting aside or setting out their performance targets for the building, they might have very specific energy savings requirements that they're trying to hit. So if they have a building and they want to get an R value of 40 for the walls, we want to make sure that that's actually what they're going to get when it's installed and put in place. Same with air leakage, performance targets, etc. Other considerations. If we have a leaky building, it's going to disrupt the HVAC system and their design air pressure relationships. And this can be really serious in sensitive applications like hospital. And even in other applications, regular buildings, it really is problematic, right? It can lead to issues such as condensation, problems with indoor air quality, rot of certain system components, or premature failure. So it's really important to make sure that we're getting a tight building, or at least a building that's constructed to the tightness that is specified for that application. It can really affect potential energy savings. Again, if your building is leaking significantly more than you planned for, you're going to have to be conditioning a lot more air. And this can account for as much as 40% of your target energy savings on a project can be affected by a poorly commissioned envelope. Commissioning limits risks associated with construction defects. And it's important to note that this is both for the owner and for the contractor. When we're talking about the envelope systems, a lot of our defects are going to relate to concealed components such as the insulation or the air barrier. So if you're not catching those until the end of the project, it can be incredibly costly to go back and correct it. So from a owner's perspective, obviously it makes sense. Let's catch these up front, make sure they get fixed. But also from the contractor's perspective, right? If you have fewer service calls or carry-on claims following the completion of construction, these items, if you have to deal with a lot of them, can outweigh the cost of the additional time spent up front on documentation and quality control during construction. And so finally, really where we're seeing a lot of the growth in building envelope is because it is a way to earn credits under LEED, and specifically LEED version 4 that's been introduced over the past few years. This is a good and bad thing, in my opinion. It's good because it really is shining a spotlight on this this area of benefit for a project. It can be a bad thing too, because when people think about LEED, they're often thinking about what's the minimum amount of effort I need to do in order to get these 2 points that I can achieve. And so they're not always thinking about how do we implement the best possible commissioning process. So I think it's just a good learning experience for everyone. It's good that LEED is out there in order to kind of draw some attention to commissioning. But also hopefully, or sorry, to building envelope commissioning. And then once we start getting in our foot in the door with clients and they can see the benefit of it, they might start to do an even more rigorous process than LEED requires. All right, so when we do talk about the process, one of the things we want to think about is what's the best way to achieve these goals and to save valuable time and money during the construction phase. And what we really want to do is start commissioning the envelope as early as possible. Now, if we do start late, the commissioning process can still assist with identifying and correcting mistakes via things like mock-up installations or early in situ installations and doing that construction review on site. However, I think we can all agree that it's better to catch mistakes during the design and fix them before they ever make it to constructed assemblies. This saves headaches for all parties. In an ideal world, the building envelope commissioning consultant will be brought in during the pre-design process while the basis of design and owner's project requirements are being developed. Unfortunately, this doesn't happen as often as it should, but regardless of when we're brought in, we do have to be flexible and ensure that we support our clients' needs whenever we are brought on board, even if it does limit the effectiveness to some extent if we are brought in later in the process. And we'll talk a little bit about that in the next few slides. So when we do start thinking about the building envelope commissioning process, it really is something that tracks through the entire construction process. Obviously, there's certain parts of construction where we're going to be much more involved than we are at others. So like I said, ideally, we're brought in right at the very beginning, right at pre-design and design development. In practice, and in my experience, we're often brought in closer to when the design team is already putting together the construction documents. And in a few cases, we're even brought in after procurement and before construction has started, when basically all the details are done and they're asking us to review at that stage, which we can certainly do, but it is much more difficult to change things at that point. So we'll talk through kind of the ideal process in the next few slides, but again, just understanding that there's a little bit of flexibility, right? As with all things in life, the ideal situation doesn't always happen. Rather, what we find is that our plan doesn't always match reality. With that said, it's easier to navigate the bumpiness of real life construction situations if we head in with a good plan and process in place, even when acknowledging that we need to be flexible as we hold on to that plan. All right, so starting in pre-design and design development, again, the real benefit of having us here or having your building envelope commissioning team in place at this stage is allows us to be involved in the development of the owner's project requirements. This is a document that needs to be put in place early in the process. And I think you all have experience with OPR, and I'm sure you have experience with really good OPR documents and really bad OPR documents. You can have both, right? Some of them are put in place the way they're supposed to at the beginning of the project and really inform everything else that's done. Sometimes they're retroactive documents that are done to check a box at the end of the job and didn't really didn't really control anything. They're just kind of put together. But we do recommend, if at all possible, that we hold a working meeting in order to draft the OPR. And again, I'm talking specifically from an envelope perspective. Obviously, there's a lot more that goes into the OPR. This document defines requirements and specific performance targets for the project. It's important to consider while you're putting it together, budgets, right? What are the owner's priorities and what do they want to meet minimum legislated requirements, or do they want to exceed them? If so, by how much? And then what is the cost to do so, right? There's a lot of considerations to be thinking about. It's also a living document that will be updated as the project progresses, right? So if we identify some things during the design stage that need to be changed, that might change, or sorry, we might decide that, yeah, we could do this, but it's going to be significantly more expensive. We can get a similar performance if we modify it this way, right? And so we want to have some level of flexibility in it. The key items that we want to define include the durability and service life of materials. What are our targets for things like air leakage and vapor control? What about water leakage? That might look like a weird one to have, but buildings are going to leak under certain design conditions, right? Not every building in Canada needs to be built to withstand a hurricane because we're not going to have any here, right? So things like thermal performance, fire resistance, acoustic performance, all should be considered and really determine what level they factor into the design. Some buildings, acoustic performance is going to be a huge consideration, say a concert hall or something, or a building that's built next to a noisy freeway where you really want to have good sound isolation from the interior. Other buildings, it might be a very minimal requirement, right? And then we want to define our testing requirements, and we'll talk about that a lot more in some future slides. Once you put your owner's project requirements together, you develop your basis of design document, and this is essentially a detailed description of proposed systems, assemblies, and materials, and illustrate how they can comply with the OPR. When you're putting together your basic design, you want to consider any maintenance requirements as well for the systems, especially if you're doing this in conjunction with life cycle costing analysis for the project. In a nutshell, the OPR defines the performance targets for the building envelope, while the BOD provides the plan for how to meet these targets. All right. Once the OPR and BOD have been developed, or in the case that we are brought in later, that we've reviewed and understand these documents, it's our job as the building envelope commissioning professional to create a project-specific building envelope commissioning plan that overviews what is understood of the schedule and organization of commissioning activities. It should also talk about how internal resources will be allocated to meet the project requirements. It should overview the roles and responsibilities of the project team members and documentation and what the documentation requirements are, including who has responsibility for the preparation of each document. Okay, so that basically takes us out of the pre-design phase and brings us into kind of design development and construction documents. During this stage, the commissioning specification sections need to be developed. Typically, we will have both some front end sections that are dedicated to commissioning procedures, as well as some notes in the technical sections for component-specific commissioning requirements. Typically, all of our envelope elements are covered under Division 7 and Division 8, with a few isolated exceptions. Yeah, typically we're looking at Division 7 and Division 8. So depending on our specific scope for a project, we may be preparing some of these specifications, or we may be in a largely review role. In either case, we need to have some oversight of the specifications so that we can suggest items to be included. Things that we would want to make sure are discussed are testing requirements, shop drawing submittals, what is required, what's required for shop drawings, what's required for other material submittals, project mock-ups for each individual assembly. When are they required? Are they on site? Are they in factory? Are they part of the actual finished building enclosure that can be kept if the mock-up passes testing, etc.? What about manufacturer site visits? Do we require them for certain components? If so, how frequently? What is the manufacturer testing? All of that should be spelled out in these sections. And we need to make sure that there's an agreement between what's in the technical sections and what's in the overall sections as well. We recommend having a dedicated air barrier section, which instead of just kind of specifying the primary materials, should include all accessory materials, transition membranes, sealants that are used for repairs. All of that should be overviewed there, as well as performance targets for the air barrier. And then in addition to component-specific testing, the commissioning section or sections should overview minimal functional performance testing requirements for the building as a whole. This might include such things as whole building air leakage testing, IR scans, roof flood tests, or others. We should also include that somewhere in the specs, there's a real clarity about the minimum number and timing of the tests. We also want to be really clear about how it's being paid for. Is there a testing allowance that's been set aside for the testing? If so, what is the contractor's responsibility, right? Typically, they would be required to make sure that there's access to the site for the testing. They would be required to pay in some cases if the test fails. And even then you want to figure out, well, what are the performance requirements for, what are the requirements for when they would be considered at fault for the failure and be required to pick up costs for retesting. So there's just a lot of things that you want to make sure are spelled out in advance so the contractor has a fair chance to price the job accordingly to what's going to be required on their end. We also want to call out the timing of the tests. And again, what we're talking about, when mock-ups need to be done, and are the mock-ups to be tested, are they be tested in a factory, on site, etc. So once we've assisted with that, obviously we'll do our building envelope design review, which includes this review of all the relevant specification sections, and we want to review them for compliance with the OPR. And then we move on to drawing review. And as I've highlighted here, transition details are really important and where we're going to focus a lot of our attention when we're doing a design review. So this process is going to include review of the design drawings. And then once we've moved on after the procurement phase, it's also going to include review of relevant shop drawing submittals. We're going to review all details for continuity of the thermal barrier and air barrier. And again, this is most important at the transition between assemblies. And we want to make sure that the detail is constructible. And especially when we get to the shop drawing review stage, we want to make sure it's clearly identified which trade is responsible for item. Have a transition membrane, and we'll see things like you have a window shop drawing and the window shows the transition membrane and it says transition membrane by others. And you can go to the cladding shop drawing for that cladding system that's adjacent to the window, and you look at theirs and they have that membrane identified and it says by others again, right? And so we want to, as the person who's reviewing the drawings, to identify that and call it out to the contractor and say, you know, you've got to coordinate between your trades whose responsibility this is. And then we also have to figure out the sequencing for that, right? What we don't want is a situation where you've got this transition membrane that maybe the cladding trade, they've decided they're responsible to put it on, but the windows aren't going to happen until weeks after the cladding is completed. And that transition membrane is just sticking there, flapping in the breeze. There's other trades working around it. The release paper gets removed, and all of a sudden it's bent back on itself. And by the time the window trade comes, it's completely unusable, right? So there's a lot of considerations like that. Aside from just, is this a good design? It's how do we actually make sure that this is built in a way that's going to work, and at the end of the day, that we're going to have something that make sure that all these transitions are properly detailed. There might be some modeling that happens around the design stage, whether that's by us or by others for us to review. And then as we do these, the design review and any changes are required, we might want to finalize the OPR with any changes that were included. So just going back to the specifications, I just threw in just a real excerpt from a couple of spec sections that might be similar to what you'd see for building envelope commissioning. In this case, we've got section 019115, which is the actual commissioning requirements for the enclosure, and then a separate section 019117, which outlines functional performance testing in more detail. And as I mentioned before, sometimes our scope includes preparation of these commissioning sections, and sometimes they're created by the design team with our responsibility to review and provide comment. And as I said, in either case, we really want to make sure that the BCxA requirements are clearly defined and that we are able to get buy-in from the contractor, right? So this is especially critical when it comes to the functional performance testing requirements. And as this is an unfamiliar service to a lot of owners, they often don't have a firm idea of what they want from the functional performance tests and which are most appropriate for their building. So again, it's important for us to talk this out early in the process, really at the time of the OPR development if possible. And that way we can ensure that appropriate list of applicable tests can be specified. If you're doing it too late in the process, it can add cost and create confusion between the design team and the contractor. So we talked about the building envelope design review. I've shown here just an example of a section detail at a door sill. And there's some issues on this, and I won't spend too much time on this, but just show some of the types of comments we might make. So here we see that there's no provision for any drainage through the door sill to get back out. They've got a continuous sealant bead along the front edge here, and there's no weep holes in it. So anything that gets behind is going to drain into this cavity. They've got a transition membrane here that extends below the sill as a attempted through-all flashing, but there's actually nowhere for that water to run. First of all, it's going to be really hard to put the membrane in the way they've shown it because it's not supported by anything below this precast sill here. And then you see here the weep vents for the brick are actually below here. So there's no water that can actually run out. So we recommend just deleting this, basically allowing any water that's in this to drain through the wall assembly and out through the weepers at the bottom. Another item here is just the way they've detailed their air barrier around this wood blocking. They've actually got barrier currently in front and behind the blocking, which if there's any moisture trapped in that wood, which we know with wood is often the case, is really going to have nowhere to go and could end up causing rot. So we actually think it's better to just make sure that wood is protected within the drainage cavity and keep it open on that backside because you still got your continuous air barrier, but in theory you can have some moisture drive to dry that out. And then the last thing here, we just talked about putting a proper water stop at the back of this door with basically an L angle to allow your membrane to be upturned. But yeah, again, when we're talking about design review, the timing of the review is really important. And sometimes it's difficult to determine when is the best time to do it. It can depend on a number of factors, including what stage we were brought in. But at a minimum, the IFC drawing should be reviewed prior to construction commencing to identify any potential problems before they require potentially costly changes on site. But of course, the earlier the design team starts thinking about envelope detailing and continuity of air barrier and thermal systems, the less chances there are for these considerations to cause other design and constructability challenges down the road. If at all possible, it's good to do a review at about the 75% design development stage. In that stage, they're usually far enough along that there are some pretty well-developed building envelope details for us to look at. Sometimes prior to that, we get detail sets and there's really very little for us to comment on because there's so little detail in terms of how systems are tying together and stuff. So ultimately, that's a pretty good stage, around 75%. That gives us a chance to kind of get still really early in the design, get our feedback, and before we're talking about IFC drawings. All right, so once we've done the design review, we move into the construction. The first real task in the construction phase is the startup meeting. This meeting is always important, but it's doubly so if the contractor was not involved during the design phase, as we need to transfer all information regarding commissioning and requirements for testing documentation to the contractor. When we're doing building envelope commissioning, we find there's many requirements for the contractor to do QA and QC that they're not likely accustomed to doing. So it's important to review their plan and make sure that they have assigned individuals to oversee each trade, and then ensure that those trades have proper QA QC procedures that are being put in place. One way we can sometimes help with that is it'll often be included in our scope to prepare QC checklists for each envelope. It's kind of a simple way for them to kind of come to site, have this daily checklist they need to go over and make sure that they're thinking about those things at the beginning of each workday. Establishing clear roles is critical. The sooner we do this in a project process, the better for ensuring a smooth commissioning project. So once we get into construction, we have a few different things that we're going to be doing on a regular basis. That includes periodic site review. The extent of our site review is really variable project to project and typically fairly limited when we're building envelope commissioning consultants. It's more kind of a high level review to make sure that there aren't any large scale issues that are kind of propagating through the construction. So if we're brought in early in the process, we're always going to recommend to the owners that they also have third-party consultants reviewing envelope items on a much more regular basis than us, to make sure that we're getting kind of down to the granular level and finding the little deficiencies that could easily be missed when we're only going out once every 2 months or something, right? So there's usually regular construction meetings. Depending on our scope, we may attend those, or our client, who is usually the commissioning agent for the project, will attend those and report back to us on any follow-up items related to the envelope. And then there's also performance testing, which can include periodic site review tests or standards-based testing that are less frequent. We'll talk about those on future slides, so I won't go into that here. Mock-ups are really important, not just for us, but they're a great opportunity for the contractors to get a test run in with their QA QC plan. And then if there are any significant changes to the design during construction, we obviously need to be a part of that and making sure that we understand and can communicate that well to the construction team. So performance testing. This is, I think, in a lot of ways what people who aren't familiar with building envelope testing or commissioning will be really interested in, what types of tests we can do to kind of verify performance of the windows. And the short answer is that, of the envelope, not just the windows. And the short answer is there's a lot of things that we really can do, a lot of different types of tests. And some of them I'm fairly familiar with. Some of them listed here, such as like blast testing or impact testing, I haven't done on any project that I've worked on. And really, again, it's going to be project specific. So we really need to determine with the team what performance criteria they will be including in the commissioning process. I would say at a minimum, we're always really concerned about air leakage and water penetration and thermal performance. The other ones are kind of on a case-by-case basis, right? And it's going to depend on the available budget. It's going to depend on the owner priorities, the type of systems. So in the next few slides, I'm going to go over some examples of various tests that can be performed. This is obviously just a sampling of the tests that are available out there. I've tried to include a lot of the most common ones that we recommend on a lot of jobs. And I'll give a little bit of detail on how each test is performed and what we're trying to detect with it. But the intent of this summary isn't to get, or sorry, the intent of this presentation isn't to get too into the weeds with that. And some of them I'm more familiar with than others. So if you have questions, I might be able to help on some. Others I might need to talk about or talk to people who are more expert in those areas to get you a proper answer back. Yeah, so one of the tests that we do on a lot of our projects, or that we recommend anyway, is astm E1186, which is essentially an IR scan of the building envelope. The intent of this scan would be to identify kind of low-hanging fruit in terms of areas where you might have issues with thermal bridging or air leakage. Typically, the test would be scheduled for a cold winter's evening when you have a delta T of at least like a difference in the temperature between the interior temperature and the exterior temperature of at least 20 degrees Celsius. You're going to get your best results that way. And then you want to pressurize the building, which involves closing all the windows and doors, closing any other intakes if possible, and then trying to set the HVAC systems to be supplying as much air as possible and exhausting as little as possible, so that you've created the pressurized enclosure so that where air has other opportunities to escape, you can pick it up on the scans. And I've shown just some examples of photos and conditions you might see from an IR scan like this. This first photo here shows evidence of air leakage around these fixed IGUs in a curtain wall application. So it looks like there must be something going on with the seal, because all along this horizontal mullion, you see these little fingers of air that appears to be escaping around it. This corner mullion at a curtain wall here looks like it's at a higher temperature than everything else, which might suggest that it wasn't insulated properly. You'll see this in a lot of buildings that have poor insulation over the slab edge and over the edge of shear walls. So you see these kind of really defined thermal bridges at the floor slab locations. There's a couple other here showing some soffits, some other thermal anomalies. Ultimately, it's the job of the technician doing the scan to identify the anomalies. If they're kind of easily diagnosable just based on the images during the scan, you can say what it is and say if there's options for repair. Otherwise, you might need to recommend additional testing to kind of drill down on what's going on. Another test that you can do is E2359. This is basically a pull testing for EIFS and basically making sure that you've got proper adhesion of your insulation panel to the substrate. Essentially, you're taking a piece of plywood, adhering it to a cutout section of your EIFS wall. You have this calibrated kind of pull rack that's going to pull it at a specified load to failure. And then one thing you can also look at once you've removed it is how adhesive actually applied. Typically with an EIFS application, you want vertical ribbons of adhesives, of the adhesive. And you can see here, it looks like they just did a kind of minimal spot application. And here's an example of the same test being done where it was a mechanically fastened system. ASTM C1153, this is a roof IR scan. And one thing that we try to educate a lot of our clients about is that they think often they want us to do IR scan and they ask us to come out and scan the roof and scan the walls. But in reality, as I mentioned with the wall scan, you want to do that in the winter when you have a really high delta T between the interior and exterior. The roof scan, you actually want to do it in the summertime, and you want to do it on a day when it's really sunny and you get a high solar load on the roof throughout the day. Because ultimately you're looking for areas of wet insulation, and those areas of wet insulation are going to hold a lot more energy from the sun and release that heat energy slower than the other areas of dry insulation on the roof. So if you have a nice hot day and then you come in after dusk and do the scan at that point, you'll see kind of the reflection of that heat radiating to the night sky. And you're looking for these kind of defined geometric shapes, which basically follow the insulation panels in the roof below. And you can pretty clearly see where you may have issues with leaks because the insulation panels are clearly saturated with water. We'll also see some evidence of thermal bridging through mechanical fasteners in the roof system. And depending on how it's designed, that might be expected, or it might be an indication that they weren't installed properly. A common test we do a lot just while we're on the field doing regular site visits is ASTM C1193, which is what we call the hand pull tab test for sealants. The intent of this test is to basically confirm that your sealant is bonded well to your substrate. We've got this little diagram here from Dow Corning's installation manual, which shows how the test is to be completed. And basically you want to cut it off as cleanly as possible from the substrate and get about a 2-inch sample. And then you take that sample and pull it at a 90-degree angle to your substrate. And you pull it to its maximum elongation and then even beyond, and you're trying to pull it right to failure. And then the passing, if the sealant is passing, that's because it fails cohesively within the material before it starts to fail adhesively and pull off of the substrate. And basically that's showing you whether or not your substrate was prepared properly so that you can get that good bite. If it's failing, you might have had a dirty substrate, it might have been wet. We have this example here where you can see an EIFS system, and you can see they've got finish coat on the backer rod, which means that the finish coat was clearly applied before the sealant was. And when you do that, that finish coat doesn't have a very good bond strength to the base coat below. So your sealant is going to pull that finish coat off and fail quicker than it would if it was properly attached to the base coat. ASTM E1105 is another one we recommend on a lot of our projects. It's a really good test for window water penetration and basically making sure that they're hitting their performance targets that are specified. The way this test is done is you get enclosure that you pressurize on the inside of the window, and that pressure is provided, I think, uniformly for part of the test and cyclically for other parts of the test, while the window is being consistently sprayed by this calibrated spray rack at the exterior. So as that window is being wetted and the test runs, you're looking for the window to complete the entire test without any water coming in. If you do see water coming in, obviously it's a failed test. And the next step is to diagnose the problem and figure out, was it an installation issue? Was it an issue that this window system that's been selected can't meet the standard? That shouldn't be the case because you should always be checking, obviously, manufacturers' test reports before you get to this stage. But yeah, you have to diagnose that and make sure you can fix it. ASTM E779 is a whole building air leakage test. This is a really beneficial test when you have performance targets for air leakage for your entire building. But also because it's a test that's done at the end of the project, once your entire air barrier is in place, I say not at the end of the project, but close to the end of your envelope construction, it's really important, if at all possible, to combine it with other tests that can be done on a more regular basis throughout construction, including testing discrete sections of your air barrier and walls at transition locations, etc., just to make sure that before you get to this stage and find out your building is failing, you kind of know where your problem areas are and can correct them as they go. When you do the test, though, if you are really close to passing and maybe you're just a little bit below your target, sometimes you are able at this stage to identify where the leak sources are and correct them. And so one thing we do to help that is actually introduce a bunch of smoke into the interior of the building while we're completing the test. And because that blower door is pressurizing the building, that smoke is going to travel towards the areas of leakage, and you can help you identify them. And in some cases, we can even plug those leaks up, rerun the test the same day, and have it pass. Another window test is AAMA 501.1. I'm actually not as familiar with this one as the ASTM standard that we discussed earlier, but it's more of a dynamic test with a blower fan from the outside rather than a calibrated enclosure on the interior. And it just another way of simulating a wind-driven rain. And then the last one I'll talk about is ASTM D4541. And this is a method for pull-off strength of coatings using portable adhesion testers. So when you're relying on a liquid applied or peel and stick type membrane for your air barrier, you want to make sure that you've got proper adhesion of it. So this can be a really beneficial test to make sure that your barrier or your membrane is properly sticking to the substrate. All right. So we've done all our testing. We've gone through the construction phase. Now we're into occupancy. And I'm running a little bit behind time. I'll try to go relatively quickly through this. Obviously, the big task here is putting together our final commissioning report. And a lot of these other items are going to kind of flow into that, right? So we talked about organizing all commissioning documentation. That's something we want to present usually to the owner with our commissioning report. There may be end of warranty period performance reviews that are included. There's almost always some level of operations and maintenance training. So what we're trying to do is you're going to have your training session for your MEP systems, And we want to include in that making sure that these operation and maintenance staff understand how to care for their building envelope systems as well. And usually, I mean, that's a lot simpler than your MEP systems, to be perfectly honest, but it's still important to know that you've got regular maintenance thresholds for your roof. When do you need to get up there and check it? When you should be checking drains? How do you properly clean your cladding to make sure that it stays looking good, but the cleaning processes don't actually affect the performance? And then there might be other things such as periodic performance reviews or verification of seasonal performance levels. We talked about, the roof and wall IR scans being done at different times of the year. Maybe when your envelope construction finished, it wasn't the appropriate time to do a wall scan, and you might want to do that at another point. So some of these tasks might be done by us. They might be done by the contractor or even somebody else on the project team, depending on the roles and responsibilities as were defined in the commissioning plan. All right, and just quickly before we end, just touch on commissioning requirements in LEED v4. So there are both the prerequisite, the fundamental commissioning prerequisite, EAP1. Now, if a project, any LEED project has to get all of the prerequisites. If a team is targeting this, but not the enhanced commissioning credit, typically they're not going to bring on an independent commissioning authority because they're not required to. The who here is a qualified member of the design or construction team. They're not supposed to be associated with the project otherwise, but they can be from the same firm. So even if they're doing this, there are some requirements for BE commissioning in the sense that they have to consider BE performance targets in the OPR and BOD, and they have to have a review of those targets in the OPR BOD as well as within the project design. Now, once you go to the enhanced commissioning credit, this is typically when you're going to get an independent commissioning authority brought in to do the job. There's an option to get 2 points for building envelope commissioning. That's under the option 2 compliance path. And it includes additional requirements, including review of contractor submittals, verifying that there are envelope maintenance instructions, including the systems manual, that operator and occupant training requirements are included in the contract documents. I want to verify system manual update and delivery, verify operator and occupant training, delivery and effectiveness, verify any seasonal testing requirements, review building operations 10 months after substantial completion, and develop an ongoing commissioning plan. So I will provide just a quick summary of what we talked about today. So ultimately, building envelope commissioning benefits all of the project stakeholders. We talked a lot about how it benefits the owners, making sure that they get what they paid for, but it also benefits the design team, having that dedicated member or dedicated third party that's going to be reviewing their design and providing input in areas where they might be able to improve it is certainly a benefit. As well as for contractors, again, catching problems early before they become really costly items to correct. We recommend starting the process as early as possible to take advantage of design review and getting those changes those recommendations basically to the design team as soon as possible so that they can change things before they propagate too far into the design. You want to determine the desired level of testing that is appropriate for a project. And again, the earlier you can do that, the better and the more smoothly it's going to run. And then as we noted that there is an available 2 points under credit EAC1, Enhanced Commissioning and LEED v4. So thank you so much. I know that was a lot of time of me talking continuously and a little fast at times, but I would want to open the floor to questions now. So feel free to unmute and I'll run through the chat too.
Yep, thanks, Caleb. No, that was fantastic. I'll start with some questions in the chat. And anybody else, you can raise your hand if you want to jump in with a question as well. So from Daniel, with the OPR, what if the client doesn't have much detail? Do you help them write one, or do they rely on the building envelope commissioning spec?
Yeah, so I guess you're and also welcome, Dan. I didn't realize you were in the session. It's nice to see you. But I believe what you're asking here is that if you have an OPR, but it's not a particularly helpful OPR, where do we come in? Did you want to kind of elaborate on that, Dan?
Yeah, that's exactly what it is. So sometimes the level of detail you might be looking for as a commissioning authority isn't called out in the OPR. So what do you do in that case? And that sounds like somebody else asked the same question.
Yeah, so ultimately it's an issue that we deal with, a lot of the time, because we are brought in late. We are brought in after the OPR is already developed, and we're supposed to be reviewing the design to the OPR. And if it doesn't have a lot of helpful details, it's pretty difficult to do. Again, in the ideal world, our scope would include a review of the OPR and some feedback to the design team that we can give. There are going to be cases where, we are limited by our scope all the time, right? So if that's not included, we have to work the best that we can to it. And I end up putting a lot of questions in the design review at that point. And it's a lot of, instead of being able to say, we think you need to fix this, it's okay, I don't like this here, but doesn't necessarily contradict the OPR. I just think it's something that needs to be looked at in further detail. And this is why, right? Try to give some context to it.
No, it's a good
Right.
one. And then a follow-up, Daniel, you had outlined that you often see whole building air leakage testing to verify air tightness of the envelope as well.
Yeah, so I mentioned that is something that we can do. And I think you talked about ASTM E1186, which is the
That was a
Whole building.
thermographic one.
yeah,
The
that's the
thermographic
thermographic
scan.
scan. Yeah, so thermographic scan, because it's qualitative, you're not seeing a lot in terms of pressure, but you're talking about how much do you want to pressurize the building.
Yes.
I don't know if that's outlined in the standard, but yeah, I mean, in a lot of cases, we end up doing the scan, and it's really hard to actually get the operators to even pressurize the building at all, right? So you're getting kind of the best possible you can, and it's not always quantitative; it's more qualitative, right? In terms of, let's close all the windows, all the doors, let's get these fans pumping, and let's try to minimize the amount of exhaust that we're pulling out of the building at the same time.
Yeah, I think from what I recall, I know small residential projects would be like 7 or 8, and then larger buildings would be 15 plus or minus. But
Yeah.
no, good, that's a good question.
And
Okay,
then in
so
terms of, oh, sorry, he had the question too about the whole building air leakage testing. So it is something we recommend. It is one of the more expensive testing options though. So in terms of how often it's implemented, we've seen it on maybe like 25% of our projects, something around that range where people will actually do it. And I do think it has a lot of benefit, but again, you really need to see, like, is air tightness and energy performance a really key design metric for this building? Then it's a lot easier to sell to the owner.
perfect. Next one here from Marie. Will this presentation be available at the end? So yes, the intent is for us to load this in the recorded session to our website. It'll be our first, so please bear with us as we try to do that. And I know, of course, Mo and Eva Backer are on, and we shouldn't have a problem. Those guys, I guess, can figure it out. Okay. From Abu Bakr, how do you manage the lack of OPR like most of our projects? I know you touched on this earlier. I'm not sure if you want to expand.
Yeah, I think I kind of answered that with Dan's. It really is the best that you can. Again, trying to get in early enough to encourage the owner to consider these things, even if it's not formalized in the OPR. But at least to have those questions in place during the design review, so they can start thinking about what they need to be doing for their envelope.
But I'm sure you do some kind of questionnaire type questions over to them to try to help them through that process as well. Give them some for instances, or ask some of that, right?
Yeah, it's something we probably should get into a little bit more. Again, we're trying as much as possible to encourage being brought in early enough to get that. But often when we are brought in, we're kind of playing catch up to a certain degree, and maybe having some questionnaires like that would be really helpful.
So from Kate, can we get a copy of the slide deck? Also, what are the testing typically performed at a minimum on a lead project? Assume simple kind of core and shell, industrial, commercial. I know you talked about this kind of early on. It's whatever you want, whatever's in the scope. There's, especially when it comes to lead, there's they don't stipulate. They
Yep.
basically give very cast a very wide net and allow the owner and project team to kind of figure it out from there.
Yeah, lead isn't really prescriptive that way. So again, we try to help encourage the approach of what are we trying to accomplish rather than how do we get 2 lead points. But honestly, if you want to get 2 lead points, there's lots of easy ways to do it. You do need to show some level of testing, but you might do something as simple as a couple sealant pull tab tests and maybe a building scan. Does that actually give you a ton of useful information? Maybe not, but you can technically show that you've met the lead requirements for it.
Yeah. Don't get me started on the checkbox kind of overall, methodology with lead. It helps and it hurts, as you've outlined. Copy of the slide deck. So this is, of course, part of the BCAs. We're putting this on as part of our chapter. We have not talked about providing the slide deck to anybody. I think for a reason, what we would like to do, of course, is to have this recorded session on our website to get access. Okay. And then if you have any other questions, comments, suggestions, as I've kind of outlined in the chat box already, feel free to reach out to our Eastern Canada chapter or myself or Caleb directly. Okay.
Excellent.
Abu Bakr,
Yes.
got another one here. The BCA have an OPR template we can provide to the owner. Yep. Nope. Thank you very much. We have on our website also a bunch of different documents through the Eastern Canada chapter on the RFP side and best practices, along with a plethora of other building commissioning documents and templates that are available. So good BCA plug for that. Derek Chung, how is this overlapping with the code required envelope testing in Toronto or in Ontario or in Canada? Good work with the presentation, y'all. Thanks, Derek.
Yeah, so are there specific standards you're thinking of in terms of code required envelope testing? To be perfectly honest, that's not an area that I'm intimately familiar with in terms of what the different standards are and what level of testing that is required out of them. So, I mean, certainly if you have a test standard in your municipality, that's going to be driving the project design, right, and what you need to achieve, then doing it as part of your envelope commissioning makes a lot of sense, right?
I think what Derek might be referring to is part of the Toronto Green Standard. I know that's one area that I'm somewhat familiar with. They do outline for the air leakage testing for that.
Yeah.
But we could we'll take that one down, Caleb, and we'll expand and outline to anyone that's interested. Okay.
Sure.
Including our good friend Derek. Okay, next one from Miguel. For air leakage tests, is it hard to achieve NECB leakage rates?
Yeah, so again, I'm not familiar with the NECB and what they call for. I know we do find in a lot of cases that people are kind of randomly picking fairly stringent numbers for their air leakage, and it can be very hard to achieve those rates. But again, if we know what we're targeting at the beginning of the project and we can work towards it, what we would recommend is a lot more testing throughout construction and a lot more targeted review during construction so that we can make sure that the air barrier is put on with a level of rigor that you don't always see. But yeah, I wouldn't target a really stringent air leakage and then just plan to do one whole building air leakage test at the end of the project and cross your fingers and hope you achieved it. You're really going to have to plan that through your entire process.
Really good point. And last is a thanks for you, Caleb, for putting this together. This was great. TYSM, I think that's thank you so much. I'm a little bit unfamiliar with that one, but nevertheless, thank you again, Caleb. Great job. Really appreciate it. As stated, if anyone has any comments, suggestions for future webinars, feel free to reach out to the ECC or myself directly, and we'd be glad to take those on this year. So thank you very much.
Yeah, thanks so much, everyone. I really appreciate it. Looks like we had a great turnout, about 50 people on the call. So yeah, we'll end now, and then we've got the recording that can be uploaded to our website at a later date.
Perfect.
Great. Have a good day. Yep.
Great job. Take care.